Hi, this is Karthika, Faculty of Physics, working in SNS College of Technology. So in this session, I am going to explain about the working applications of photodetectors. So here we can see the principle, construction, working advantages, disadvantages, and then application. So photodetector is an essential component in an optical receiver that converts incoming optical signal into electrical signal. Semiconductor photodetectors are usually called photodiodes because they are main type of photodetectors that will be used in optical communication system due to their quick detection speed, high detection efficiency, and small size. At present, the photodetectors widely used in industrial electronics, electronics communication, medicine and healthcare, analytical equipments, automotive and transport, and many other. These are also known as photosensors and sensors of light. A photodetector is an optical electronic device that is used to detect the incident light or optical power to convert into an electrical signal. So usually this output signal is proportional to the incident optical power. This can be used for many scientific implementation like process control, fiber optic communication system, safety, environmental sensing, etc. So next we can see the principle of photodetector. So it converts the light photon energy into an electrical signal. Photodiodes convert light energy and also detect the light brightness. The temperature range of photodetector ranges from 8 Kelvin to 420 Kelvin. The photodiode temperature ranges from 27 degrees Celsius to 550 degrees Celsius. So now we can see the construction of photodetector. So it is used two semiconductors like an P-type and P-type in this design. The formation of P-type material can be done from the diffusion of P-type substrate, which is slightly doped, and P-ions layer can be formed because of diffusion method. On the substrate of N-type, the N-type epitaxial layer can be grown. The development of P-type material diffusion layer can be done over the heavily doped N-type epitaxial layer. So the contacts are designed with metals to make two terminals like anode and cathode. The front region of diode can be separated into two types like active and non-active surface. The designing of non-active surface can be done with silicon dioxide, and an active surface the light rays can strike over, whereas on the non-active surface the light rays cannot strike, and the active surface can be covered through the material of anti-reflection so that the energy of light cannot lose and the highest of it can be changed into current. The working principle of photodiode is when a photon of sample energy strikes the diode, it makes a couple of electron hole pairs. This mechanism is also called as the inner photoelectric effect. If the absorption arises in the depletion region junction, then the carriers are removed from the junction. Therefore, holes in the region move towards the anode and the electron move towards the cathode, and photocurrent will be generated. The entire current through the diode is sum of the absence of light and the photocurrent. So the absent current must be reduced to maximize the sensitivity of the device, inbuilt the electric field of the depletion region. Next we can see the different mode of operation. Here we have a different modes. Photovoltaic mode. In this mode is also called as a zero bias mode, in which a voltage is produced by the lighted photodiode. So it gives a very small dynamic range and non-linear necessity of a voltage form. Next one is the photoconductive mode. The photodiode used in this photoconductive mode is more usually reverse bias. The reverse voltage application will increase the depletion layers width, which in turn decreases the response time and the junction capacitance. So this mode is too fast and it displays the electronic noise. Avalanche diode mode. So avalanche diodes operate in a high reverse bias condition, which permits the multiplication of an avalanche breakdown to each photo produced electron hole pair. This outcome is an internal gain in the photodiode, which slowly increases the device response. So next we can see the advantages. So it has less resistance, quick and high operation speed, long lifespan, fastest photodetector, spectral response is good, does not use high voltage, frequency response is good, solid and low weight, and it is extremely responsive to the light, dark current is less, high quantum efficiency, and then less noise. So the disadvantages is nothing but temperature stability is poor, change within the current is extremely little, therefore they cannot be enough to drive the circuit. The active area is small. Usual PN junction photodiode includes high response time. It has less sensitivity. It mainly works by depending on temperature. It uses offset voltage. So here we can see some of the applications of photodiodes. This can be used in charged coupled devices, photoconductors and photomultipliers, and also that is used in consumer electronic devices like smoke detectors, compact displays, televisions and remote controls in VCRs. So in other consumer devices like clock radios, cameras, light meters and then street lights, photoconductors are mostly used rather than the photodiodes. Thank you.